Okay, so if in case you didn't finish the foldable or for some reason you missed the PowerPoint review yesterday, I do need you to finish this. This is the next thing we're going to put in. I'm going to stamp this before you leave today. And we're going to start on the homework. So this should just be a review of what we did. Yes. The worksheet you picked up is the homework. So that's after all of this. Yeah. Okay, so we're looking at the figures change, but the shape stays the same. We hit some of these key points a little bit yesterday. The pre-image and the image are similar, so that's why it's a similarity transformation. Also, K is what we use for the scale factor universally. Sometimes they use a C or N or A. It's going to be a variable. The size change from the original to the image, okay, it's always proportional. Now, these two rules that we're going to talk about, because we're going to hit basically the center, okay, our center of dilation is the point that we're going to have the proportional relationship from. So if C is on C, it's equal to each other. So the center is the same. The minute I do K, which is our scale factor, I do K times R, meaning I'm multiplying the scale factor times that length. That's how it became the image, and it got bigger. So yesterday we also talked about what creates the dilation that's an enlargement versus a reduction. We're going to get into compressions, which talks about a stretch and shrink vertically or horizontally. So that's our key information. In our table that you have underneath this, and I'm going to scroll this up a little bit. All right, so for your scale factor is the number that is multiplied to your X and Y coordinates or the side of a figure, okay? So we're multiplying the scale factor to our coordinates, to our pre-image, or to the side of a figure. Now, we did this yesterday. If it's an enlargement, to enlarge a figure, K has to be greater than 1, okay? If we're going to reduce a figure, then K has to be less than 1, but greater than 0. So it has to be between 0 and 1, a fraction or a decimal. And if it's going to be produce a congruent figure, then K equals 1. K will be equal to 1, and it will produce a congruent figure. Now, to find the scale factor, since our scale factor is represented by the symbol K, it's a ratio of the image to the pre-image. So K equals your image to the pre-image. Another way to calculate that or to think about that is saying whatever your new side or length is to your original. Okay? Compare the new to the original. Ethan. All right, so we're going to look at some test-like questions and some properties that you need to be able to apply. And we got to do something. Anyone know when the test is? Thank you. Yeah, because like y'all ask me this almost like every day, and I keep telling y'all, and it's on the calendar. Okay. All right, so number 1 and 2, flip your paper over. Okay, so if I ask you to find scale factor, it will be from a picture or off a coordinate plane. Okay. Just to recap, so if I give you these two pictures, we have D prime, A prime, B prime, and 2 D primes. I see that. That should have been a C. Okay. All right, so what is the picture? What's the scale factor? Yeah, K is 4. Okay. To get that, I look at my new, which is the 48 inches, to the original, which is 12. 48 divided by 12 is 4. Okay. All right. Now, same thing on the coordinate plane. How am I going to calculate the scale factor for the coordinate plane? Yeah, look at your coordinates. That would be one way. So if I look at A prime, because I'm always comparing the new to the old. So if I look at my coordinates for A prime, I have 6 and 3 for my Y, and I have 2 and 1. What are those both reduced to? They both reduce to 2. Okay? So my scale factor would be 2. If I have horizontal or vertical lines, I can count. So this one was 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 and 4. And then 8 divided by 4 is 2. Okay? So if they're horizontal lines, because sometimes I'm going to give you that, just count. Okay? Work smart, not overwork. All right, the ones that you're going to need to be familiar with, circle 4 and 5, those are more test-like. Okay? Yeah, 3 and 4, excuse me. I'm sorry, 3 and 4. 3, 4, 6, and 7. 3, 4, 6, and 7. Okay? So picture will be given or coordinates will be given. So let's see if we can determine the scale factor for 3. I'll give you a try. Okay, scale factor for 3. Anyone? It is not 2. It's not 2. Okay, first of all, our dotted lines here, we're going to see an animation of this, but you need to be able to do this because you're going to sometimes get a center that's not the origin. But basically, these lines are connecting the image and its pre-image together. So we're just going to label that point right there as your center of dilation. So please pay attention so you don't miss this type of problem. The distance from our center of dilation has to remain proportional. So if I'm looking at, let's say I give this center C, okay? The distance from C to F, the pre-image, is 6. Everyone agree with that? Okay, so then when I dilate it, the distance from C to its image F prime is not 12. It's 18. So your scale factor is 18 over 6, which is 3. It was an enlargement by a factor of 3. The distance from the center of dilation has to remain proportional. All right, so on 4, the prime, we can look at A or B prime or C prime. I'm just going to look at C prime to C. We're going from 9 to 3 or -3 to -1. What's the scale factor here? And it was also 3. Okay? You can get that from the order pair. All right, so now, no graph. Okay? Determine the scale factor. So we're still going to compare the prime coordinates to the original coordinates. Okay? So this first one, yeah. 3.5 or 1.5. Okay. 6 is 2. Okay. And then here K is 1/2. Yeah, it goes from the prime. Okay. Oh, well, yeah, it goes here to here. Yeah. It always goes to the prime to the new, basically the prime to the O, to the original. It's not left to right. See, this is your prime here. Okay, and it changed to that. Yeah. Oh, so this should be 1/2. Yes. Look, look. Prime. It is reverse. Yes, that's what I'm saying. Yes, okay. Oh, because the other two are in the prime was the second point. Yeah, okay, yeah. Yeah, yeah, he's right. It's going to G to G prime. Yeah. It's flipped. Okay, if you have two colors, good, but we're going to look at the relationship, yes? 2 over, what number? What number? Okay. Okay, guys. All right, if you want to highlight your image, that's what you can do to show two different colors, but we need to plot our pre-image. We're going to draw the quadrilateral ABCD, okay? So we're at 0, 1, negative 3, 2, negative 4, 0, and 2, negative 3. All right, so what quadrilateral do we have here? Maybe, just by... Not a kite. Okay. All right. We're going to plot the image under the transformation. X and Y is now going to be 2x and 2y. So the scale factor is 2, and we're going to multiply to the x and the y coordinate. So already, I'm going to scoot this up just a little bit. We're just going to put in and graph it. So we should have 0, what was it, 2, and then B was negative 6, 4, negative 8, 0, and then 4, negative 6. Right. Okay? I multiply the coordinates by 2. And then we're just graphing that point to show that this is basically an enlargement. Negative 8. A prime. B prime. Oops. I missed one. Negative 6 and 4. C prime and D prime. Okay. They want us to find the slope of A to B. So the slope, rise over run from A to B. Up how many? Up 1. 1, 2, 3. And it's negative 2. Yeah. Sorry, my bad. All right. Slope of A prime, B prime. Slope of A prime, B prime. All right, compare the slopes. What conclusion can you make now? How do we know that? Well, say you're absolutely right. Okay, so A, B is parallel to A prime, B prime, because same slope. All right. Not congruent. I can only talk about the slopes being parallel. Congruent would mean I have to now do the distance formula, okay? All right, now, write an equation for A, our image, our pre-image, AB. Look at AB. We know the slope is a negative 1/3. What's the y-intercept for AB? Because that's the easiest way to get to it. Yeah, it's 1 in it. Yeah, so y equals negative 1/3 x plus 1. All right, now we're going to do the same thing for our image, A prime and B prime. What would its equation be? Yep. And then compare them. Well, we know they have the same slope because they're parallel. The only thing that changed in the equation was the y-intercept, right? And look at that, 1 to 2, okay? So, different y-intercept. All right, now they want us to compare the lengths. So, to find the length of AB, AB, you can use your distance formula, basically use your slopes, the original slopes. your rise over run, like a squared Pythagorean theorem. So we know it's 1 and -3, right? Squared. 1 squared plus 3 squared. That gives me a total, when I do my order of operations, 10. So AB equals actually the square root of 10. Okay? Now let's work smart, not overwork. And I want to check your rational and your radical relationships. Make sure you know your rules right. What's the scale factor here? 2. So to get to A prime, B prime, basically we're just saying 2 times AB, right? All right, so if that's true, what is the length of our image? No. No, that's what I was hoping not to hear. Thank you. It is 2 the square root of 10. When you do 2 times the square root of 10, you cannot take what's on the outside and multiply what's on the inside. That's not how you simplify or multiply radicals. So that was the whole point. With our next unit, you're going to have to be very precise with radicals. So we're going to get into using it a whole lot more. All right, so 2 times, square root of 10. What's the relationship? Double. It should have, because that's the scale factor, okay? Now, before we do this real quick, I need to show you something. Okay, so look real quick. All right. This first one I gave you, these lines, this is important, so don't stop what you're doing, please. Knowing how to create these lines connecting the image and your pre-image is very important, because not every dilation is at the origin. For example, let's just look at the dilation. If I want to show it increasing, you see, look at what happens with the polygon. Okay, do you see how the points of vertices stay on that line? Okay, now, if I want to show it decreasing, now you were asking me, can the scale factor be a negative? Look what happens if it's a negative. Look where the shape ends up going. Almost like a reflection. Yeah, it just has a scale factor. Look at the scale factor up here. If I'm decreasing, right here, now it's a negative. See what happened to the shape. All right. Okay. All right, now, look. What this is showing you is those lines always intersect. Do y'all see that? The center of rotation, or dilation, excuse me, is always the point where those lines meet. And you are going to have to identify that center and use the center to basically dilate a point by a different scale factor. So I can move this center, and it doesn't matter where I move it to, those lines will always intersect. So with that being said, here's your first thing. I've given you the image and the pre-image on number 11. You need your protractor for this. I'm hoping. Okay, so on 11, we're going to draw a line connecting an image and a pre-image vertice, okay? So which vertice do you want to start with? All right, let's start with A. I'm going to do dotted lines. It's up to you if you want to do the same, okay? All right, so I'm going to go to A, draw a line through A to A prime, and I'm going to extend the line. You need to extend the line so that you find the point of intersection, okay? Make sure you extend your lines. Now, how many lines do we need to find a point of intersection? 2. We have to have at least 2 lines, okay? It takes 2 lines to have a point of intersection. So I don't need to connect all vertices. I just need to connect at least 2 pairs. So which other 2 do you want to connect? All right, so we're going to do B and B prime. So I'm going to draw a line, if it lets me. I'm going to draw a line through B and B prime. And find where they intersect. Oh, I gotta move this one. Yep, 2, -3. So that right here, you put a point there, and you would say that is your center of dilation. This is the point we are dilating that image from. Okay? All right, try the next one. You're definitely going to have this on an assessment. I guarantee. Okay? 11 and 12 are test like. Odds are it will probably be a multiple choice. But you have to determine the correct dilation point. Okay, so besides the center dilation, okay, last thing, and then I'm stamping. Besides identifying the center dilation, I'm going to give you a new center dilation, and you're going to dilate from that point. Okay? So first, we start off with plotting the center dilation. I already gave it to you on this example right here. This is our center of dilation. Okay? The C. All right, so we're going to determine the coordinates of one pre-image point by looking at your slopes, by looking at your vertical distance, okay, and your horizontal distance. So all I want right now is the slope from C to A, from our center to our pre-image. What is our rise over run for that? 1 over -3. Yes, okay. So because our dilation is going to be a scale factor of 2, we're just going to multiply the vertical change, the distance, which is the 1, and the horizontal distance, the -3, by 2. So that means our slope from center dilation to A prime would be 2 over -6. We just multiply our original slope by 2, by the scale factor. So I'm just going to start from the center, and I'm going to go up 2, and then to the left 6, and there is where A prime will be located. And then you just repeat those steps for each vertex, okay? So if I'm going to do the slope from the center to B, I'm counting up 1 over 1, right? 1 over 1, which is 1. Then to do the dilated point, okay, from basically C to B prime, 2, 2. You have to keep equal distance because you want to keep it proportional. So now from the center, I'm going up 2 to the right 2, and there's our B prime. And now I can create my image segment, okay? Now, I do want you to work smart, not overwork. Does anyone understand our way to get to B without having to use your slope? Once we have A, think about it. Once we have A, yeah, A and B is a straight line. We know right there it's what, 1, 2, 3, 4 units, right? So all I have to do is make this one 8. Once I had, you have to figure out at least where A or B is, and then just count it out. Yes. Okay. All right. So on your homework, go to your homework. Go to the back of your homework. All right. On your dilation mix, guys, because I'm going to see if you can at least do one. And we're going to look at question 2 on the back. Okay, so it's going to be helpful, especially if you're going to use your slopes, to create vertices to make up this letter M, okay? So there are my vertices to make up the segments that draw or create the letter. Now, start off by plotting your center, which is 2, 2. I'm going to label that X, okay? We're dilating this by a scale factor of 1/2. Okay, our C is our scale factor is 1/2. First, find your slope from your center to a point. So this is up 2 over 2, okay? Then we're going to take half of that. So that now makes it 1, 1, and there is the image of that point from the center. So if I'm doing, let me put that in green. So if I'm doing this point, I go from C to that point. That is up 6 to the right 2. So now I start at the center, and we go up 3 over 1. There it is. Does that make sense? Yeah? I went up, I'm sorry, 3. No, up 3. You're right. Sorry. 1, 2, 3. Yes. Okay? Because we're dilating, it has to have the same shape. Well, look at our shape. This has got a negative slope of down 2 to the right 2. Well, if I do half of that, that's going to be down 1 over 1. There's your, and then it reflects over. You kind of see what we're doing here? See if you can get the image graphed. Where's my stamp? On number 4, our center of dilation is at 6,4. I'm going to make that X. Work smart, don't overwork, because this is a right triangle. Okay, I'm going to put vertices A, B, C, just to help make sure you see what points I'm referring to. All right, so find your slope, your vertical and horizontal from X to A. That's down 2 to the left 2. We're going to do a scale factor 2. So how do I now move? 4, 4. Okay, so we're going to go down 4 to the left 4. There's your A prime. All right, so let's work smart and not overwork. We got a point, right? What do we know about from A to B? That's 2. So that means now if I do a scale factor 2, that's to the left. 1, 2, 3, 4. There's your B prime. And look at between B and C. It's 2 as well. So that means I'm going up 4. There's your C prime, and we are done. Don't let a dilation of a center of 0 confuse you. You can still use your point here and use your slopes if you want to. But basically, if it's at 0, you can just multiply your sides, your vertices, and get the new vertices. Okay? So, for example, my vertice here for B is 4, 2. Okay? All right. Since the dilation's at the center, then I can just say the scale factor 3/2 times 4 and 3/2 times 2. What would this A prime be? If I took 3/2 times my 4 and then 3/2 times my 2. Yeah. So that would be your order pair for your A prime. That's only when it's 0. You can just go straight to multiplication. Okay? So that's like a shortcut. Okay? So the only ones you really need to focus on that are not or have a little bit more steps is when the center is not 0. Yeah, like so you could if you wanted to do your slope, but since we know this is going to be 6, 3, then I'm just going to now go over 6, up 3, and there's my point. There's A prime. No, not when it's at 0. Yeah.